Hey everyone, welcome back to my channel, The Daily Scope. Something terrifying is about to happen on June 17th. NASA is about to send a spacecraft into a place where no human-made object has ever gone before. Into the fiery jaws of the sun. The Parker Solar Probe, the fastest spacecraft in history, is diving straight into the sun's most dangerous zone. A region so hostile, so blisteringly hot that even signals might not escape. Why is NASA risking this? What could be so important that they're willing to sacrifice a billion-dollar probe? The sun, our life-giver, is also our biggest threat. A single eruption from its surface can fry satellites, shut down global power grids, and blind entire cities. And now, the Parker probe is heading right into the heart of that chaos. What will it find there? Will it even make it out alive? Or will June 17th become the day we lose contact with one of humanity's most daring missions? Keep watching, because what happens next could redefine everything we know about the sun and our survival on this planet. The Parker Solar Probe is not just another space mission. It's a technological daredevil, a spacecraft designed to kiss the sun. And on June 17th, it will make its closest ever approach to our star, venturing just 6.2 million kilometers from its surface. That's less than 4% of the distance between the Earth and the Sun. To put that into perspective, if the Sun were a basketball, Parker would be flying just a few millimeters above its surface. No other probe has ever attempted such a feat. But why is NASA doing this? I put a fragile piece of technology into a literal hellstorm of heat and radiation, because the Sun is still one of the biggest mysteries in our solar system. We rely on it for life, yet we understand shockingly little about how it really works. Solar flares, sunspots, coronal mass ejections. These explosive phenomena can have devastating effects on Earth, but we don't fully know what triggers them. We don't know when they'll strike, and we don't know how to stop them. Parker's mission is simple in concept, but extraordinarily complex in execution. Fly through the sun's corona, the superheated outer atmosphere, and collect data on solar particles, magnetic fields, and the energy bursts that can ripple through our solar system. But there's a catch. The corona isn't just hot. It's insanely, murderously hot, over 1 million degrees Celsius. And even though the sun's surface is cooler by comparison, the outer atmosphere is where things get chaotic. To survive, Parker is equipped with a revolutionary heat shield made of reinforced carbon composite, capable of withstanding temperatures up to 400 degrees Celsius. Behind this shield, delicate instruments are tucked safely, kept at room temperature, despite flying through a furnace. But as Parker gets closer to the sun, the margin for error shrinks. Even a minor malfunction could mean instant death for the probe. In June 17th, that's when Parker enters its most dangerous phase yet, perihelion. It's a point where it's closest to the sun and its current orbit. This is where the spacecraft will gather its most valuable and riskiest data. During this close approach, it will fly at speeds exceeding 586,000 kilometers per hour. That's fast enough to travel from New York to Tokyo in under a minute. It's the fastest object ever made by humans. At that velocity, any particle, any stray piece of solar debris, could punch a hole right through the spacecraft. And yet, it must go forward, because if it succeeds, the payoff is huge. Scientists believe Parker could answer one of the biggest mysteries in astrophysics. Why is the sun's corona hotter than its surface? It defies logic. Normally, things get cooler as you move away from a heat source. But not with the sun. The surface is about 500 degrees Celsius, but the corona above it can be up to 200 times hotter. Parker might also explain how solar winds are born. The constant stream of charged particles flowing from the sun that can slam into Earth's magnetic field, causing geomagnetic storms and beautiful auroras, or GPS blackouts and power grid failures. And let's not forget the threat of coronal mass ejections, massive explosions of solar plasma that can launch billions of tons of material into space. In 1989, one of these shut down the entire power grid of Quebec in just 90 seconds. What if something like that happened today? NASA knows we're not prepared, and Parker might be our best shot at building an early warning system, or at least understanding when and how these solar bombs might go off. But here's the thing. Every time Parker dives in closer, it risks everything. The sun is unpredictable. Solar flares can erupt without warning, sending a shockwave of energy that could destroy the spacecraft's systems in seconds. The probe is also increasingly vulnerable to communication blackouts. As it gets closer, it can't send signals in real time. Instead, it must store all its data and wait until it's a safe distance to transmit back to Earth. That means we won't even know if it survived June 17th until hours, maybe even days later. It's like sending a message in a bottle into a volcano and waiting for it to float back out. And if Parker fails? That's not just the loss of a $1.5 billion mission, it's the loss of vital knowledge. It's a step back in our race to understand the one force that could, quite literally, wipe out our way of life. Yet, despite the danger, this mission has already achieved incredible things. In its earlier flybys, Parker discovered switchbacks, strange zigzag patterns in the sun's magnetic field that no one expected. These could be key to solving the mystery of the solar wind's acceleration. It also gave us the first up-close view of a dust-free zone around the sun, a region where cosmic dust gets vaporized by solar heat. That's something we could only theorize before. Every pass Parker makes brings it closer to solving mysteries that have puzzled scientists for decades. Every byte of data is priceless, yet every time it dives closer, the odds grow worse. There's no repairing it, no rescue missions. If something goes wrong, that's it. So on June 17th, as it makes its 17th close approach, everyone at NASA will be holding their breath, because this pass isn't just about science. It's about proving that humanity can reach out and touch the edge of a star and survive. The Parker Solar Probe is more than just a machine. It's a symbol, a messenger of our species' courage and our hunger to know. On June 17th, it enters a zone where metal can melt, electronics can fry, and data might never come back. But if it succeeds, it will give us a glimpse into the very heart of our solar system, the chaos that powers it. This mission isn't just about the sun, it's about us. Our technology, our understanding, our future. Because the more we learn about our star, the better we can protect our planet. But here's the question we'll be asking in the days after. Did Parker survive? And if it didn't, what exactly did it see before it went silent?